Okay, so we want to do 10.3, number 57, which is simplify this thing. Okay, so we want to simplify the cube root of 22 over 99.
No, it's perform each indicated division by rationalizing the denominator and then simplify.
Okay, so simplify, note to self, rationalize the denominator. Okay, cool.
Which means
Let's see. So if I want to simplify this just without thinking about directions at all, what's the simplification I can do to this right as it is? Okay, so I could notice that this is the cube root of 2 times 11 divided by 9 times 11, right? And then in here I could say, the 11 over 11 is a onesie, right? So really this thing is the cube root of 2/9. Cool? Okay, this is simplified, right? Now they said also you should probably rationalize the bottom. This is not a step I really am so worried about your ability to do. This thing came out of an old system before calculators. Now calculators are so prevalent that I don't really care if you can do this step, but let's figure it out anyway. So when they say rationalize the bottom, what they mean is get rid of the cube root on the bottom somehow. Okay? So let me think about this. This guy is the cube root of 2 over the cube root of 9, right? Is cool with that? Okay, how close am I to being able to cube root 9?
Okay.
Yeah, I can square root 9, right? But I can't cube root 9. So maybe I could introduce something on the bottom so that I could cube root 9. Does that make sense? Yeah, like if I multiplied by another 3 in here, then I could cube root the bottom, please. You guys see that? Okay, so how am I going to put that in there without changing things? Yeah, multiply top and bottom by something, right?
square root of 9, square root of 9.
Cube root of 3. So the 3 is so I get 27, right? Why the cube root? Yeah, because I can't stick them together unless the root matches. You guys see that? If I had the square root here, cube root of 9 times the square root of 3 is, I don't know how to stick those together. They're not like terms.
Okay, so we can just throw this extra 3 in because it is the square root of 9?
Okay, careful. That's a good question. I can't really throw anything in here, right? I just changed something by throwing this in there. So how do I make sure I'm still equal?
Top and bottom.
Yeah, I've got to do it top and bottom.
But I'm getting the 3 because it is the square root of the 9, correct?
I'm getting the 3
Because
I want to, yeah, I want to
I
get
get it now.
something cubed.
I get it now.
You guys see
Go
that?
over this with me just in math lab.
Okay, so let's see. What do I get out of this? Okay, on the bottom I get the cube root of 27, right? That was the point. On the top I get cube root of 6. Then the bottom I can evaluate, right? What's that? 3. So I get the cube root of 6 over 3. Yeah?
Can we write that cube root of 9 is approximately to
So the reason I don't want you to approximate is that you lose this hard equal sign, right? I'm often interested in having a hard equal sign because that allows me to specify my error later, right? If I use an approximately equal to, I'm specifying an error right then. And if I find out later I wanted more precision than that, then I have to go all the way back through the problem. You guys cool with that? All right. So this is the thing they were looking for out of this one. We were looking for cube root of 6 over 3. You guys want to know the why you would rationalize the bottom?
Yeah.
The why for this is sort of, okay, you got this out of some problem, right? This thing you started with. And now you'd like to compare it to a number you know about, right? Like, is this number bigger or smaller than a half? I have no idea, right? But if I can make it thirds, right? I could say, okay, now it's 2 cube root of 6 over 6's, and then I could compare it to 3 6's. Right? Does that make sense? No? Okay, say I wanted to compare this cube root of 2/9. I want to compare that to a half, right?
Okay. You got half a pie, you're gonna give me another half.
Yeah, exactly. I've got this much pie. I want to know, do I get more or less than a half a pie, right? Okay, so I take this thing, I do this business about rationalizing to the bottom. I find out that this thing is the same thing as the cube root of 6 thirds, right? I still want to compare to halves, right? So I should think to myself, okay, this is 3/6, right? This one is 2 cube root of 6's over 6, right? So now instead of comparing this messy thing to a half, I'm really comparing 2 cube root of 6's to 3. Okay, see that? I found a common bottom between thirds and halves, so 6's. Okay, see that? So now instead, I'm wondering how does 2 cube roots of 6 compare to to 3, and then this I can ballpark easily. You guys see how I can ballpark this? So what's the cube root of 6? How about what's the cube root of 8? 2. What's the next nearest one that I know about? 1, unfortunately. So I know that this is between 1 and 2, right? You guys see that? So 2 of them is between 2 and 4. Well, it's about the same size. You guys see that? Just kind of got that? So if I'm comparing to 1/2, they're about the same size. If I'm comparing to 1, this thing's smaller. You guys see that? So this is why you would do this, so you can kind of compare by hand without using a calculator. That said, we all have a calculator in our pockets nowadays, so this skill is kind of unnecessary.